Okay, well, today I'm going to give an update of 5G. And if you can hear it, hopefully in the background, everybody will know what this song is, or what the title song is from. It's the good, the bad, and the ugly. And when I was thinking about the presentation, it was the title came to mind when talking about 5G. And the good is that definitely more equipment. It's been about 2 years now that it's been rolling out. Carrier coverage has gotten a lot better. They're adding a new mid-band, the C-band area, which is giving more bandwidth. Private 5G networks are being rolled out also, mostly for businesses, and they're deploying edge computing. The bad is that problems with the hardware still exist, and there are security issues being uncovered. And then the ugly, good old patent wars, political issues. And guess what? We're going to be having 6G rolling out in around 2030. The good, there's a large selection of 5G phones and in a broad price range. For example, the Apple iPhone 12 is the first phone that Apple really has, which has 5G. And that has, it's a 4x4. In other words, it has 4 transmitters and 4 receivers. So you can see it can be paralleling the signal with all 4 going, and you'll have a lot broader bandwidth that way. The other thing is that previously, I'd say, let's call them first generation 5G phones, typically only covered part of the spectrum. For example, T-Mobile and T-Mobile and AT&T used the sub 6 gigahertz frequencies to as their carrier frequencies. Now they all have the sub 6, the lower. They also have the new C-band, which are being produced also, and also the millimeter waves, the 24 and up gigahertz bands. There's new equipment coming out: Cisco, Ericsson, Huawei, Nokia, Samsung, ZTE. They're all releasing new core equipment, which is adhering more and more to the current release of the 3GPP. Because of the changes in release 16, prior to that, a 5G network had to have a 4G anchor to it. With the release 16, it removed that requirement. And now a lot of upstart carriers are coming out. For example, if you have a factory and want to use 5G to implement manufacturing, where all the robots and the delivery and trucks like that would be talking to each other, it would be, you can use a private 5G carrier to install it and use it. The other thing is some places like the Marines are implementing a private 5G network where they'll have virtual reality training and a lot more capabilities than just phone service. One of the things that allows that is that with 5G, if you remember, it not only will talk to the base station, but will also talk to the other other equipment. So for example, you can have direct video to video contact between, say, let's say two soldiers in a virtual reality system, and it doesn't have to go through a base station. And because of that, it's going to reduce the latency. So you can get, you won't have any lag in what they're observing. The other thing is you can then also bring a lot of servers to the edge, as they call it, which is closer to the user, and that way it's going to be communicating with a lot less latency. Just to show you how the coverage of all the services are going, I took the three major ones. Verizon 5G coverage. If you look at this, the little dark red dot, the 5G ultra wideband, that's the millimeter wavelength. And as I mentioned before in the last talk, that because of the propagation, it doesn't work well in the normal environment. People tend to want to, actually what they're finding is it's better in confined environments such as stadiums or venues where you have a lot of people congregated. I believe that the Madison Square Garden was one of the test sites. With the pandemic, I don't know what the status of it is right now. The other thing is that the 5G nationwide, which is similar, well, what they're doing is they're basically congregating the bandwidth using the 5G protocol. And so they're using the sub 6 gigahertz bandwidth to get that propagation that they need to be able to offer 5G to a broader area. And then again, 4G LTE is what we've already had in the past. And here's a shot of us here in Summit. And as you can see, in Summit, we're in a 5G nationwide area. But if you look around, there are spots that only have 4G LTE coverage for Verizon. And there is one, Jersey City is a hotspot for the ultra wide band. Going to AT&T, it's a similar issue. They haven't been rolling out their what they call 5G plus, which is their millimeter wave system as much. I believe the only location is Washington, DC, and I believe they might be looking at Boston. But as far as other, there are fewer cities with a millimeter waveband that they're implementing. And again, here's another look. That's Summit's location, not a 5G plus. I don't have any connections with AT&T, so I'm not really having a 5G plus in my house. But as you can see, they do have a lot of 5G coverage. And again, as with Verizon, sporadic 4G LTE coverage here also. And then again, T-Mobile, nationwide 5G LTE. And again, they're very limited in their millimeter wave locations. T-Mobile and Sprint have merged, and here's their local services in the Summit area, New Providence. So as you can see, 5G has really been rolled out to our locale pretty in a pretty wide area. The other thing is, remember, this is 5G, and typically it's not going to be, it's going to be the sub 6 gigahertz and not the higher millimeter wave lengths. The C-band is a new spectrum that they're adding to the availability of the spectrum, and C-band, for those of you who may not know, is from 4 gigahertz to 8 gigahertz. And the lower C-band that the phone companies have been bidding on and purchasing, and I believe the last count, it was about 80 billion in bandwidth that they've paid for it, is from 3.7 to 4.2 gigahertz. This band was originally used by satellite TVs, and if you remember the old days where you had the big 12-foot dish in your backyard trying to pick up satellite signals, that's all gone away. They're using higher frequencies now. They can use smaller antennas, and so the FCC has been able to grab the lower bandwidth and use it. Actually, the iPhone 12, even though it wasn't publicized, actually is certified for the C-band, and Samsung Galaxy, Google Pixel, and LG Wing, though I don't know if you've heard, LG is leaving the phone business. They've also been certified for C-band. So when the carriers start pumping it out, your phone will be ready to use it. As I say here, Verizon's about ready to start rolling it out, probably later this year. AT&T and T-Mobile Sprint, it'll probably take them until about 2022, if not sooner. Again, it depends upon, do they have they purchased the spectrum that they are going to use, and do they have the equipment in place? And now I get to the bad. One of the big problems is how carriers are going to recover their investment for the 5G rollout. They originally tried to charge more for 5G, but found out that a lot of the customers were not happy about that. And then they went ahead and limited your amount of data, and also the customers weren't happy with that. And so pretty much they've gone back to the basic plans, and the competition is driving them down, so that the only real way they're going to be able to recover their investment is through either adding more customers or providing a service, for example, by having edge computing, having something closer to your network with faster speeds, lower latency, such as Netflix or one of the other streaming services. They would guarantee that you would never get a buffering window. The other problem that they've been having is with the equipment itself. As you can think, as I said, there are 4 transmitters and 4 receivers, and each one is pumping out some milliwatts, and we all know that generates heat. And so they get quite warm when they're being used heavily. And that also implies that your battery is going to be draining a lot faster. And as I also mentioned, that with your data plan, if you are on a limited data plan, you may burn through it quite rapidly. For example, a 2-hour movie can theoretically be downloaded in about 3.5 seconds with 5G full out. Apple tweeted, there were quite a few customer complaints about it. And Apple's solution was to turn off 5G and go back to use LTE to extend your battery life and to reduce the overheating. Because again, with LTE, you're only using really one transmitter and one receiver to connect to the base station. Another thing is, again, as with almost everything, as it's been out, people have been working on it, testing it, and they have discovered that there is a networking problem with the way the bandwidth is controlled with network slicing, and it makes a denial of service attack possible on the carriers. They've also haven't seen it in the wild, so they're not completely sure that it's going to be a major problem. But again, they're having the carriers look at ways to circumvent that. And now the ugly. The ugly part of this is, again, all the fighting. The standard essential patent holders are the companies that hold the patents for the standards parts of 5G. And as I'll show you in the next slide, it's not it hasn't become the standards committee. It is these companies that then go ahead and can license their patents. Huawei has started demanding royalties from Apple and Samsung, and we'll have to see what happens there. Samsung has also started to demand royalties, but actually Huawei is cheaper than Samsung, so it'll be interesting to see what happens. And then the political issue. As you know, there were trade restrictions put on Huawei and the other Chinese companies, and pushing our base stations to be used by Samsung, to be produced by Samsung non-Chinese manufacturers. The US, UK, and Australia all agreed to do that, but actually Canada has not, and they are using Huawei equipment. Here I show the number of standard essential patent shares held by each company. As you can see, Samsung is the leader in the number of patents it holds for the 5G network, followed by Nokia, Qualcomm, Huawei, LG, Sharp, and Interdigital and MediaTek. The thing about it is that, remember, it might be, for example, with Huawei, it might turn out that what AT&T and what Apple might be using and Samsung might be using is one of the parts of the protocol that Huawei developed. And that's why you're getting these patent fights back and forth. The other thing that is coming out to replace the or to be used with the 5G network is the Internet of Things. And this was a slide I gave the last time, and we're now post-release 16. And one of the things you might not be able to see here is, but one of them is what they call V2X, which is vehicle to everything. And what this is would be a standard which would allow your car to talk to other cars or even other cell phones. So for example, if your car sees that you're walking across the street, and hopefully you have a 5G phone, it will know to stop and not hit you. If you don't have a 5G phone, hopefully the AI that they've built into the car will recognize you and stop in time. The other thing is with the edge computing, artificial intelligence can be moved closer and closer to the customer, and that way, for example, the better artificial intelligence can be built into a vehicle, and it would be able to react a lot quicker. So that's where we are now. We're heading towards release 17, which is going to add a lot more features and a lot more of the Internet of Things. And then we're looking at the 6G, which again is targeted for 2030. And what you can think of 6G is more of a three-dimensional propagation of 5G, I mean 6G. And what it is going to be a communication not only between base stations and clients on the ground, but also satellites, airplanes, and total world communication without having to be within the range of a certain cell site. So that's the end of the slides. Let me just get out of this and get back and open it up for questions. Raise your hand. Paul, you have one. I see your hand is up.
Yeah, a couple of things occurred to me along the way. Sorry, I think I missed your first talk, and I don't know how much was about 5G, but my recollection is that at these higher frequencies, the propagation distance is less, and that would suggest that you would need more cell towers in order to get coverage. So so have they been building more cell towers? Are they less visible than the old ones, which we can all see alongside the road? And can they also just use the existing 4G cell towers and actual antennas and just have them do 5G, or maybe do both at the same time for different clients?
The 5G antennas with the standard have built-in beam steering and a lot of other features that, for example, multiple input, multiple output, which gives you the ability to have 4 transmitters and 4 receivers in your phone. They are using the cell towers and the 4G network to give that broad bandwidth capability. What you don't have is the millimeter waves, where you would have much larger bandwidths and speeds. To compensate for that, they're using the multiple input and multiple output to add bandwidth. So, for example, a typical 4G network is 200 megahertz bandwidth. What they're looking at by adding 4 transmitters and 4 receivers is that can be expanded to 800 megahertz, which gives you a lot better performance. And somebody had mentioned that they have a 5G phone and they are seeing good bandwidths. It does it does provide, I'll say, better bandwidth, but not the maximum that can be provided. And the funny thing is, in South Korea, their customers are actually suing they pay extra for 5G, and they're suing the 5G telephone company for not providing the service they said they were going to provide, and want their money back.
Well, that actually leads to the next question. I mean, for ordinary users, what advantage, is there for us? So, I can download a movie in 3 seconds instead of a minute, but not people aren't doing that all that often. And so just for ordinary service, is it going to be more reliable, or what are the consumer advantages?
Well, the one big consumer advantage is that since it has multiple input, multiple output, there's probably a factor of 10 at least higher number of connections that an individual cell tower can provide. And by doing that, they can so a normal user would not perceive the unable to service not available or not able to connect issue. Because of that, there are also, for example, I forget if it's AT&T or Verizon, but one of them is doing the essential services for the fire, police, and medical, and will give them supposedly guaranteed communications between all for the fire, police, essential services.
You can hear me.
Yeah, now we can hear you. Yeah.
Hi, Georgia. Interesting talk. My question, I don't know if this is the same thing, but suppose I've got a router that has 5G and 2G. And number one, is that the same as the 5G that you're talking about?
No. You're talking about 5 gigahertz.
Oh, okay. That's one.
It's what that is the Wi-Fi routers have 2 bands in them. The original, which was the 2.3 gigahertz, and then they added the 5 gigahertz band into the mix to give you better bandwidths. And actually, the current release, the AX protocol, 802.11ax, is very similar to the 5G network in that it has multiple input, multiple output, beam steering. And so if you have a router that has one of is an AX protocol, it can do channel aggregation. So you can have 2 a 2 gigahertz and a 5 gigahertz band also connected.
Yeah, I think it's funny because my 2G, I can go outside almost and still get it. My 5G, I almost have to be in the same room with it.
Again, yeah, it's again the propagation error, propagation ability through the house. It depends upon the construction. In older houses, they like to use a wire mesh as a screening for putting up the plaster. And of course, wire meshes make a great Faraday cage and cut down the propagation of high frequencies.
Thanks, George.
Okay, next is Al.
Yeah, George, I have one of those older houses with metal screening, actually, those old sheet metal with tangs that hold the plaster, and it makes the reception very difficult within the house, at least on the ground floor. But my question was really about showing my ignorance of 5G technology. I was intrigued by your mention that you have 4 transmitters and 4 receivers at work. And is that just for redundancy to improve reception, or can you give me a quick explanation?
No,
as
they're
to
actually
why?
they're being all used. And so you're actually bundling 4 channels together to transmit and 4 channels to receive. And since it's full duplex, you're getting all the 4 transmitters bandwidth out and back. So it's increasing your bandwidth quite dramatically.
Mm.
So in other words, just to be clear, there's the data that you're sending, it gets chopped into consecutive chunks, and they get allocated to different transmitters and received at the other end and then put back together.
Right.
So it's, and then on top of that, my understanding is that if you only have one antenna in a device, it's used both for sending and receiving. And so that means while it's in sending mode, it can't be receiving, and vice versa. And since the communication protocols require two-way transmission all the time, they send the packet, they say, did it get received? And you get an okay, and they move on. If you can use two bands and do sending on one end and receiving on the other, then they both can be going all the time. So you get actually immediately a doubling of, or potentially a doubling of bandwidth.
Also, there are also techniques where you can put in a circulator where you can use the same antenna for transmitting and receiving. So they're looking at putting, for example, the cell towers all use that, so they don't have to have 2 different antennas for transmitting and receiving. They can actually use the same one. The phones themselves, I don't know. I don't believe they have a, actually they might have a circulator built in by now. But I'm really not sure whether the phones have that.
Okay, next we have Al Aho.
Hi, Al. Well, but by the way, congratulations.
Thank you very much, George. An interesting topic is how much latency reduction is there between LTE and 5G? Supposing I have a haptic app in New York interacting with a haptic app in San Francisco. Do you happen to know how many milliseconds it takes for the signal to go from New York to San Francisco, or on 5G versus LTE?
Specifically, I don't know the answer to the cross country, but to answer your question about latency, if you're looking at, let's look at the picture of 5G, period. We won't even talk about 4G right now. So with 5G, if I'm going to talk to, let's say, a Netflix server in California. The latency you're going to see again is going to be the propagation delay because it has to go cross country. So you're going to see probably maybe a 2-second, 3-second delay in the propagation. The concept of reducing the latency is, again, to move the servers out to the edge of the network. So you'll have, for example, Netflix buffering servers close in every major city, let's put it that way. And therefore, the latency to both to be able to get to that server is a lot faster than the latency that it would take to go to a centralized server. And that's how they're getting the improvement in latency.
My question is actually motivated by a total concern of where is the latency budget being expended? Because let's say I'm doing haptic surgery remotely. My signals have to go through the software, the app, the operating system, and so on before it even gets into the network. And I'm wondering, is the reduction in the latency in the transmission going to be noticeable in all these applications that are being talked about for 5G if they're done on a cross-nation basis?
A cross-nation basis, you'll see some improvement, but not that much, because a lot of the latency will be due to the propagation across the country. The network again, one of the goals in 5G was to reduce the latency in the protocol. And what they're looking at, again, is to, for example, instead of having to go to California for the surgery, for the surgeon to do it remotely, you would have somebody in New York City doing the surgery here in Summit. So the protocol itself has reduced the latency quite a bit, but again, we're always stuck with the speed of light. If you look at, as I mentioned, in the future with 6G, and you're going to be going up to satellites, again, you're going to have more of a latency problem.
Okay, thank you very much, George.
Sure.
Okay, next is Mitch.
That damn speed of light, what a pain in the ass.
Yep.
Two things. First of all, just an observation. You mentioned the V to X stuff, and I find that incredibly powerful in the world of mobility and so forth, because what we're going to see is, I think you kind of touched on it, but just let me amplify, the vehicle talking to a digital waypoint. So instead of having a stop sign, we will have a digital stop sign, and the vehicle will be talking with that sensor / receiver / communicator. And so we'll have that, plus, of course, the communication with, say, McDonald's as you're driving along, and maybe McDonald's will say, turn in here right now and you'll get a 50% off of your cup of coffee or something. But the V2X thing has a lot of potential, and and in the not awfully distant future, we can envision, once we get rid of the legacy vehicles, basically no physical signage, and certainly in the very near future, a reduction in the physical signage, because we don't need to have as many signs as we have now, because people are using more and more V2X kind of communications. That said, my question, George, and Paul touched a little bit on this. If I use my phone for, voiced mail or voice and email and text, and let's just say that's it, I don't download any movies. do I need 5G? And if I do, what am I going to use? What am I going to see different?
No, you really don't need it. Uh, the only case you might need it is if the example I gave you about the V2X, where the car and you have or don't have 5G between you. Because one of the things 5G does allow you to do is have device to device communication. So, for example, your car would be talking to my phone and saying, okay, I see that there is a 5G device coming in front of me. Do I need to react to it? A lot of the car manufacturers right now are looking at putting 5G into their cars for the V2X protocol. The major drawback, I think, what will happen is you're going to have people coming up and saying, well, you have this in my car now. Now, are you going to be using it to track where I'm going? Are you going to be using it to charge me a mileage tax? A lot of these other questions that have been arising recently.
Well, and of course, they already know where you are and where you've been, so on an instantaneous basis. So they can, in fact, map exactly where you've been. And by policy, they do not do that, which means that there's some really cool things where they anonymize the movement and they can see, for instance, I saw some really cool data on what happens at 2 a.m. in Morristown when the bars close and who goes home, what vehicle goes home, and what vehicle stays in the parking lot, and what vehicle goes to the mistress's house, let's just say. Anyway, yeah, but I could see very quickly dynamic mapping where, we have a fairly dynamic mapping with things like Waze and so forth now, but if you could get to the point where it would say, hey, go this route because there's, a backup at this particular stoplight 2 blocks ahead. That's, I think, going to be happening fairly quickly, and that becomes fairly powerful, but at a much more granular scale than just simply rerouting you if I-80 is closed in the middle of Pennsylvania.
Yeah, that's true. And one of the objectives would be to, as you said, have this finer granularity on where each vehicle is. And that way to also avoid accidents and to be able to, for example, if a car is traveling and you're coming to an intersection and it detects that it's the car isn't slowing down for a red light or a stop sign, it can break your car and be able to slow you down so there's no collision. And getting back to Alejo's comment, that latency is very much reduced because, again, it's your car talking to the other car, talking to the stop sign. So you're all within proximity of each other and it can react quite rapidly.
All very cool future. And speaking of futures, Alejo, I want you to figure out how we can get a lecture on haptic surgery. I'm really intrigued by those 2 words. Anyway,
Can somebody just say what it is? I just Googled it and it's interesting, but I don't think many people have heard the term. Could somebody just, Al, maybe say what that means?
Haptic is, I think, of robotics involving haptics, sensing with your fingers and so on.
Yeah.
And trying to get computers to do that.
And so to do it at a distance. So if you're doing remote surgery across the country, the surgeon's on one side, the patient's side, and the surgeon needs to get the tactile feedback as opposed to just visual feedback, and that's critical to a surgeon. So there's a lot more, presumably there's a lot more data that needs to be transmitted.
Paul, you are good. That's exactly why I asked the question.
And again, and that's also why cross country, you're still limited with the speed of light,
Oh,
even though it won't be as slow as current communications.
well, let me mention, when I was at Bell Labs a long time ago, I once asked the question of where is the latency in the telephone network making a call between New York and San Francisco? And the answer is the operating system of the computer. It took
It's switching
more
system.
time to go through the software in the computer than it did to go across the nation on the transmission network. And
Well, yeah. One of the objectives of 5G was to reduce that.
well, that
Wow.
involves optimization of programming languages and compilers, which is probably just as difficult as getting light to go faster.
Right.
There are also
Gee,
two.
Al, do you know anybody that knows something about compilers and compiler languages?
Let me just say there are two components to latency, and they probably need to be distinguished. One is making the connection initially, and discovering the node at the other end, and then doing the handshake and to set up a stream, and then so that takes extra time. And but once the route has been established, and all the routers in between have been programmed to let this byte stream through fast, then there's the time it takes for the actual bits to get from one end to the other.
Good point.
Yep.
But also, as I mentioned, if you're within range, for example, as I said, New York City and let's say Overlook here in Summit, you can actually connect the remote surgeon with the local device, and so they're talking directly. They're not
Right.
going through any
Exactly.
switching network or any delay in that respect. They're looking at that. For example, I mentioned the military, the Marines are looking at it, and they would be able to use a remote bomb disposal unit robot using the 5G protocol, and to go out and disarm bombs or anything similar to that. And again, it's the operator talking to the robot directly on the 5G network.
Okay, next up is Marv Pincus.
Hello. I am technologically deficient in a lot of respects with the iPhone that I have. I still have the 6S, and I rarely, if ever, use streaming services on my iPhone. I do it on my computer or on the TV. I only have 1 gig, and I rarely even use that. I use Wi-Fi here or anywhere else. If I go to a friend's house, I use their Wi-Fi, or even the hospital, I volunteer there, I use their Wi-Fi. Is there any real reason why I need to? I think Mitch asked the question also. I think you may have answered it. Is there any real reason for me to convert to 5G or buy the iPhone 12, for example, or am I okay just using the old-fashioned 6S?
No, you're if you're not a heavy user, using the old phone is fine. Just remember that probably the next release of the Apple iOS may not support the 6S, so it's going to be falling further and further behind in the software area. It's going to be ubiquitous in that all the manufacturers are going to have the 5G in their phones. So if you buy a phone from, let's say, anybody within the next, I'd say next year, in 2022, I'm pretty sure every phone, just like now, every phone has LTE in it. Every phone will have 5G in it, whether you use it or not. The real advantage to it would become, and I really don't see this happening far into the future, where you wouldn't use Wi-Fi. Everything would be just using the 5G or the 6G. And so you wouldn't need a cable provider. You wouldn't need a Wi-Fi router. But again, that's when the Internet of Things becomes really spread out quite a bit, and I don't see that happening for quite a while.
Thank you.
But just,
But by the way, one other thing about not streaming, I'm the same way. I usually will leech on to a Wi-Fi connection, but there's always, especially with public Wi-Fi, you also have a security issue. So if you use 5G, you can have gigabit upload and download speeds when you're at Starbucks or somewhere else, and it's secure.
No, thank you.
let me just add, though, that completely independent of 5G, it's not good to get too far behind on whatever device you're using, just because there are always functions that will no longer be supported. And when new versions of operating systems come out that are more secure, they only go back so many levels. And I happen to have an Apple SE, which probably nobody even knows, but it's essentially the same technology as what's in your phone. And I'm to the point where probably by the end of the year, I'm going to get something new because I'm concerned that the next level of those releases won't support my phone.
So part of what we're saying now is one reason to buy it is to future-proof your phone
Yes.
against changes or new features that will be coming down the pike. But the problem with that is that, well, maybe George, you can address this. With the changing standards and the new releases of the standards, if I buy a device now that has 5G and I don't use it for 3 or 4 years, is it still going to work with 5G of 3 or 4 years in the future because things have been tweaked?
That's a good question, because a lot of the protocol is built into the silicon. The modems that are connecting you to the 5G network, most of them are, as I mentioned, the release 16 protocol. And again, if you adhere, they all are going to be backward compatible. In other words, so if you buy a 5G phone now, you may not be able to use some of the services that will be coming out, but you still will be able to use it as a 5G phone. For example, the people who purchased a 5G phone a year and a half ago or 2 years ago, their service, typically, if you bought a Verizon phone, it had the millimeter bands in it. If you bought a Samsung, it only had the sub-6 gigahertz bands in it. And so it would not have the ability to talk to the millimeter when the service becomes available.
Just to answer Mark's question, why should I buy an iPhone 12 now? And interestingly, a better answer might be because it has a much better camera. And there's an analog, I think, between 5G telephone service and the cameras, because they're putting multiple cameras into these phones, and the multiple cameras work together to give you better images, like better range of brightness. You know, you take one you take two pictures, and one is adjusted for the bright part of the picture, and the other is for the dark part, and then it's combined internally in the camera, and you get a much better picture, that sort of thing. And it's like multiple antennas. They're using multiple cameras as well.
Yeah. And also think of it when you want to see your grandkids and if they have 5G, you can get 4K video of them now that the phones support 4K.
Yeah, there you go.
So it's a good idea not to stay too far behind, but you don't have to jump as fast as all the marketing employees tell you should. Okay, Tom Pate is next.
Yes, can you hear me now? No.
Yes.
Okay. Talking about how fast technology moves, the system doesn't move that fast in the sense of technology upgrades. If you remember, the early cell phones were all analog, and it took, I think, 15 years after the TDD system was first introduced before that was no longer supported. So if you've got a phone today and it's doing what you want, you can probably use that for the next 5, maybe 10 years before they no longer support your technology. But if you use apps on the phone, that's a different story. The apps, they don't support back too far, as everyone has said. If you've got an app that you really love and they come out with a new upgrade and you got to put the updated software in, you may not be able to use that anymore because it's your operating system doesn't allow it. You're stuck. The multiple antennas and multiple transmitters in the 5G, everybody says it gets hot and it drains your battery like mad, and there is no way around that. So if you want a phone to use and watch Netflix, you're gonna have to keep it plugged in a lot of the time, because otherwise you're not gonna have a connection. The battery usage with 4 transmitters is very, very high. I was a hardware guy, so
Yeah.
I know that stuff quite well. And the older phones even had multiple antennas and multiple transmitters to compensate for the Rayleigh fading. So if you have 2 antennas spaced a little difference apart, the reflection and the sine wave coming in is in phase in one and out of phase in the other. You've always got something that's good, and the phone automatically switched between them. So that's a little bit of technology that nobody probably cares about but me.
No, I care about it. And actually, that's what they're using to do the beam steering. So your phone will actually do a little beam steering also to be able to optimize the signal.
Yep. Yeah, we had the presenter on a little while back, Mihai Banu, who was talking about making product to enable the beam steering more easily. One of the things he did not talk about, but I know has been done, if you do beam steering the right way and you can get a narrow beam, you can actually reuse the same frequency for multiple times. So you shoot the signal down to somebody who's only a half a mile from the cell tower, and the same direction, a guy who's 4 miles out, you can have another beam going out to him. So that's one of the tricks that have been used to increase the capacity of the system, because the bandwidth that's available, the frequency bands, is limited. You've got to reuse everything to take care of all of the users that you've got from the Verizon, the AT&T phones that are out there. So
Yeah, and that's why 5G gives you that increased number of inputs and out. You can have many more connections by using techniques such as beam steering and other methods to increase your bandwidth and number of customers, number of connections.
okay.
Okay, Ed Atkin is next.
Okay, I have a Samsung Galaxy 8 Plus. I find it does, basically what I want. From what you're saying, the newer phones, like the 5G, the battery life is much shorter. I know in my mother's case, they also say the older Galaxies are made sturdier than like the 5G phones. I found one thing I found with the basic smartphones, they didn't support certain apps that we found out when we went to the US Open was a big problem in my mother's case. So I got her an upgraded phone. Do you know anything about the sturdiness of the phones? The Galaxy's 8 Plus sturdier than the new ones that have more glass in general?
No, but one of the if you look at, for example, Apple, I'm really not familiar with the Samsung construction process, but Apple has been slowly improving its robustness of their phones. And for example, they're now using more and more ceramics, which gives it a better survivability of impact and waterproofness and other things to make it a sturdier phone. I assume Samsung is doing the same thing. Actually, they might have even been first, because I remember they're the ones that were claiming that you could put their phone underwater, but you couldn't put the Apple underwater.
Yeah, that's one reason I have the Samsung phones, for the sturdiness. Yeah, and ruggedness over the app. I've never had an iPhone, and I noticed one thing with the basic phone is they didn't support basic smartphones. The older ones didn't support certain apps.
Again, that tends to be due to the operating system.
Was the operating system. I got the new basic ones seem to support more apps. Let's say, like if you go to a ball game or something, everything is now mobile ticketing today. You're not getting paper tickets anymore. You have to,
Yeah, but usually that's just a text message with the QR code on it.
But you couldn't do it on certain Samsung phones before they upgraded that.
Again, it's the phone either doesn't have the one of the things about a lot of the phones, and we mentioned that with the iPhone, is that they stop upgrading the operating system maybe 2 or 3 generations behind.
Right.
And so a lot of the services that you are getting in a new phone won't be available in the older phones.
Correct. Okay, thanks very much.
Sure.
Okay, next is John Machida.
Okay, I just want to make a comment on latency and speed of light. I don't think the speed of light is a major limiter of latency in the 5G. If you make a back of envelope calculation, it takes 1/60th of a second or 15 milliseconds for light to travel 5,000 kilometers, which is more or less coast to coast. So I think that most of latency comes either from the operating systems or buffering data, something we can do something about. We cannot do anything about the speed of light, but we can do something about everything else.
With the 5G, if you think of it, the 2 devices would be connected. So if you look at the circuits, again, the propagation is becoming, because they're connecting device to device and not having to go through a a um, a controller, a switcher, let's say a switcher, that, yeah, probably the latency would be in the base units transmitting back and forth and through the core network. So again, yeah, I agree that it is an issue. And again, the objective is to wring out of the protocol all things that would cause latency. And so they're really trying to get it as fast as possible.
Right. But the speed of light, I mean,
Yeah, no, I agree with you. I agree with you.
you can have a conversation with somebody on the West Coast, which goes over fiber optical network, and hardly notice any latency. So, you know.
Yeah, and conversely, if you use a satellite to go international, you do see a delay in latency quite
Yes,
a bit.
right, that's right. Because this is so much larger, yes.
Yeah.
Right. Okay.
Okay, David Badisher.
David, you have to unmute.
Okay. hear me now?
Okay.
Okay. I have a fairly new AT&T cell phone. It does have some of the applications, but it's not a 5G. AT&T has recently told me that I will have to get a new phone by 2022 because they will no longer support the anything, I guess, below a 5G at that time. So I will be, of course, I'll be, and I don't mind going to the 5G. But one of the issues that I may have to encounter is in terms of I was thinking of the iPhone 12, but now I've heard that the iPhone 12 has a special magnet that was not on previous ones that could affect, like, for example, I have a pacemaker and so I'd have to be very careful. I'm wondering if there's other, like Samsung or some of the others I might be able to get around that by using a different phone. And also, I just wanted to let you know that AT&T has told me that that they're not going to be supporting, in my case at least, anything less than a 5G after 2022.
Well, in respect to the pacemaker, I really don't know. It's any electronic equipment with a transmitter and a receiver can interfere with the pacemaker. I think it's more of the transmitter and receiver than the magnet itself. But again, I haven't seen actually any studies or reports done on the phones in respect to pacemakers. As for them, AT&T discontinuing LTE phones, I'm surprised about that. What I think they will do is carry the legacy phones, but just not upgrade them.
Okay, thank you.
I just Googled and AT&T will not support less than a 4G LTE in 2022. So if you've got an older phone, then that could be a problem. But if it's
I think
4G, shouldn't be.
Yeah, I think it's less than a 4 LTE. That may be the issue.
Yeah.
It may be a 3 instead of a 4.
That is the reason to be cautious about, even though your phone works, periodically, I would guess, let's say at least every 4 years or so, you ought to seriously consider upgrading just so you stay current, because otherwise you're going to run into problems with something or other.
Yeah, this is a rather new phone, but I'm actually looking forward to getting a 5G because even though I haven't, like Mitch, I haven't been using a lot of the new features or the features that would be in a 5G. I'm interested in exploring some of the possibilities of using them, maybe when I should be using it if I had the capability. So I'm hoping that would give added capability for experimenting on some of the issues as we go forward.
Okay, this may be our last question, at least the last one up currently. Ted Bassman.
Yeah, two things here. A couple of years ago, the latency was a real big issue with electronic trading in the stock market. And this was even going from one side of the Hudson to the other. And they found out if they were going out to, say, Chicago, microwave actually was faster than fiber. So there are a lot of issues in there. The other one is with the Marine Corps. As a retired soldier, one of the things you don't want to do is draw attention to your position. Rambo would have been shot by his own fellow soldiers because of all the attention he would draw. So here I find myself with the Marines with these transmission, like waving their hands going, here I am, and you know that's going to draw incoming fire. So there's a limit to what you can do here. That's about it.
Yeah, I think it's more meant for training than actual in the battlefield arena. But yeah, actually, if you look at it, more and more of our military is carrying more and more electronic hardware. And if you have a signal sniffer, you're making yourself a target.
Well, this might be okay if you're working against your regulars where they might not have all the hardware. But if we're going against the Russians or the Chinese or their allies, they're going to have all these goodies.
Oh,
and
yeah.
you really lose your training. It's the same thing. How many people know how to use a paper map anymore?
Right. They might also have control of the hardware itself because it's their hardware that they put into our devices.
Yeah.
I think you have to assume that that's an exposure. I don't think you can assume that they're not using it.
I wanted to, George,
yeah.
I wanted to ask that very question, actually, I forgot. There's all this controversy about whether the Chinese, whether we should not buy Huawei equipment because the Chinese government can force Huawei to allow them to basically put in back doors. How do you see that? I mean, is that seriously? Do you think has it happened before? I seem to recall there was a time in the past where somebody discovered that there was stuff on chips that were made in China that was for spying purposes. And so if that's true, that means they have you can't really believe them now when they say, oh no, we would never do that. So what's your view on that?
My view is that it probably does have backdoor or spying equipment built in. I believe the case you're talking about was maybe 2 or 3 years ago when they uncovered.
What I recall was more, but it could have happened more than once. Go ahead.
But they uncovered in the circuitry this device that looked like a spying device. And when they questioned Huawei about it, they said, oh, it's for testing.
Mm-hmm.
As everything, it's testing.
And I think that little bit of that little component on the chip was not in the specs that were sent to them for manufacturing. That's the only reason they noticed it, because I mean, it's a little hard to reverse engineer a complex, processor like that.
Yeah. Okay, I think we don't have any more hands. It is 1 o'clock, so probably we'll adjourn for today.
Thank you all for your help. Thank you, George.
Thank you.
George, thank you.
Thanks, George.
Thanks.
Obviously, you promoted lots and lots of questions, so thanks a lot.